Hi there, I'm Jason, and you're watching
Jason!
Which of the following is a whole number? A. 0, B. -1, C. square root of 5, or letter D. Pi? What is your answer? Now, in order for you to answer this question correctly, you must be familiar with the different subsets of real numbers. Now, there are actually subsets that are included or under the real numbers, and let's start from the bottom. So we have here the counting numbers. So when we talk about counting numbers, when we count numbers, where do we usually start? So diba, we count starting from number 1. So therefore, the subset or the numbers included in this counting numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. So again, magsugod siya sa 1, 2, 3 hantod katapusan. So that's the counting numbers. And counting numbers are also called as the natural numbers. Now second, we also have whole numbers. So what numbers are included in this set of numbers, kaning whole numbers? So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, dot, dot, dot. So the only difference between the counting numbers, the set of counting numbers, and the set of whole numbers is simply this one, 0. So, ang counting numbers again magsugod sa 1, but ang whole number or whole numbers magsugod siya sa 0. So in other words, 0 is included in, or 0 is classified as a whole number. So next we have integers. So what are integers? So minkag integers, these are actually the positive and the negative values of the whole number. So mo na yung mga example, we have 0, 1, 2, 3, 4, 5, 6, dot, 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 and also its counterpart, which are its negatives. So we have -1, -2, -3, dot, dot, dot. So mo na yung mga integers, positive and negative numbers. And take note also that 0 is neither positive nor negative. So 0 dili na siya positive, dili po na siya negative. Now we also have rational numbers. Now we to talk about rational numbers, examples, so we have fractions. So kailan naman tag fractions, no? So ang mga nabilong gani nga numbers kanang mga fractions. So again, fractions. We also have repeating decimals. So what are examples of repeating decimals? So we have here, so may tag mga repeating decimals. So we have here 1.2222222 dot 3.4545454545 dot and 5.555555 dot. And there are more examples under repeating decimals. So may kag repeating decimals na ay nagbalik-balik ra ang iyang mga sumpay, ang iyang decimals walay katapusan. So kaning 3 dots, this actually indicate or this actually mean ellipsis. So ellipsis tawag ani, and ang pasabot ana it's infinity. So walay katapusan. So many examples of repeating decimals. From the word repeating, so nagbalik-balik and walay kahumanan, nagbalik-balik ra jud siya. And then we also have terminating decimals. So by the way, katong ganina, that's repeating, this one repeating and non-terminating decimals. So nagbalik-balik na siya and it never stops. So yeah, you have to take note that it's repeating and non-terminating decimals. And we also have repeating decimals. When talk about repeating decimals, so I mean terminating decimals, so it's simply like from the word terminating, so it terminates. So for example, 0.5, 1.2, 5.5. So wala na sumpay ani. Nahuman na siya, it stops. So it's either one decimal digit lang ani, or 2 or 3. Basta kay dili siya infinity. Walay dot ana sa tumoy. So these are examples of terminating decimals. And then we also have integers, whole numbers, counting numbers. So in other words, integers, whole numbers, and counting numbers are included in the set of rational numbers. So again, ang rational numbers apil sa daan niyang integers, whole numbers, and counting numbers. Kaning silang tulo na belong ni sila sa rational numbers. And we also have irrational numbers. So, sa imong angay ra hinumduman when you talk about irrational numbers. So examples ani are non-repeating and non-terminating decimals. So example, ana, we have here 0.123456789. So as what you can see, walay nagbalik-balik and it's non-terminating. Wala pud siya naputol, wala na human. Na may that. So it is an ellipsis. So patsabot nga, it's infinity. So it's this kind of decimal never stops. So mo sila non-repeating and non-terminating decimal. So we also have 3.45, 445, 4445, 44445. So na kay makita ani nga murag Slurpee pattern. So kani 4 na 44 da 4444444. Pero you have to take note of this kaning ellipsis. So again, wala man nagbalik, although nagbalik ra ang 4 og 5, pero ang iyang pattern dili. So dari isa ra ka 4, duha ay isa ka 4 kani nahimong duha, kani nahimong tulo, kani nahimong upat. So that's what non-repeating and non-terminating decimals are. So and we also have this one, 7.2 742561983 dot dot dot. So walay nagbalik-balik and it never stops as well. So these are examples of non-repeating and non-terminating decimals. And then we also have square roots of non-perfect square numbers. So mga square root of non-perfect square numbers, we have square root of 3, square root of 6, and square root of 11. And there are more numbers that are included in this subset. So may kag non-perfect square numbers, katutos lang mga numbers nga dili perfect square. So what are perfect square numbers? Di ay 0, 1, 9, 16, 25, 36, 49. So may kag perfect numbers, perfect square numbers. So you are going to square the whole number. So from 0 above. So mo na ilang mga perfect, mo na yung mga perfect square numbers. Like for example, 0 squared, that's 0, 1 squared, that's 1, 2 squared, that's 4. So those are example of perfect square numbers. So if you're getting the square root of non-perfect square numbers, then the answer will be included in this subset of real numbers, which is the irrational numbers. And we also have pi and e. So usually in elementary, you are allowed to use the value of 3.14 as the value of pi. And in high school, usually kay 3.1416, but pi actually is a large number. Or, I mean, this number never stops. So taas pa na siya sumpay. Gi-approximate na natin 3.14 or 3.1416. And E is actually Euler's number. That's approximately 2.7. Yeah, that something like that. And so all of these numbers, all of these sets of numbers or subsets of numbers are included in the real numbers. So in other words, may kag real numbers na siya ay duha ka category basically. So we have irrational numbers and rational numbers. And then under rational numbers, so we have integers. Under integers, we have whole numbers. And under whole numbers, we have counting numbers. So imagine lang sabton, si counting numbers na belong ni siya sa whole numbers. Si whole numbers na belong ni siya sa integers. Si integers na belong ni siya sa rational numbers. O si rational numbers na belong siya sa real numbers. Si irrational, mora na siya yung mga numbers that are not included in the rational numbers. Okay? So, let's proceed. Now, let's go back to our question. We have which of the following is a whole number? Is it A, 0, B, -1, C, square root of 5, or letter D, pi? So, the correct answer for this question is, of course, it's 0. So again, 0 is the starting number under the set of whole numbers. Now, let's try to do this. Let's do more. Let's have this practice exercises. So let's classify whether the given number is a real number, an irrational number, a rational number, an integer, a whole number, or a natural or counting number. So first, we have 10. So sa man is 10? Rational, and sa man counting what? So first, tuming kag 10, 10 is, of course, it's a counting number, it's a whole number, it's an integer, it's a rational number, and it's also a real number, of course. So, consider mo nga ni teacher, so be particular of your answer. Kaya basta yung answer is counting number. So you have to take into account that 10 is also a whole number, an integer, a rational number, and a real number. Okay? Now let's proceed. 2/5. So 2/5 is, of course, it's a rational number, it's a real number. Diba? 2/5 is not a counting number, of course. Dili man siya counting number, dili man siya whole number. And it is also not an integer. So, ano ta sugo na? 2/5 is a rational number, diba? Fractions are included in the rational numbers, and it's also a real number. How about this? 2.5. So, of course, 2.5 is a rational number and a real number. So particularly sa rational number, so it is a it's a terminating number. And then we also have 6.123.123.123 ... Sa Manisia. So it's a rational number and a real number, of course. It's not a counting number again. It's not a whole number. It's not an integer. It's also not an irrational number. It is a rational number. So about 1, 2, 3, 1, 2, 3, 1, 2, 3, ... It's repeating and non-terminating. So balik-balik naman ang 1, 2, 3, 1, 2, 3, 1, 2, 3. Diba? So therefore, it's a rational number and a real number. And we also have 3.12123.123.4 ... On sa mani, it's an irrational number, and of course it's also a real number. So sa may difference ani niya sa previous nga exercise. So ganina si 1 2 3 1 2 3 1 2 3 nagbalik-balik lang ang 1 2 3 1 2 3 o 1 2 3, but this one 1 2 1 2 3 1 2 3 4 ... wala nagbalik-balik ang kasunod nga mga decimals, diba? So that's why it's an irrational number and a real number, of course. And how about pi? So of course pi is an irrational number and a real number. What about this? E. E is an irrational number and a real number. How about square root of 19? So of course square root of 19 is an irrational number and a real number, because 19 is not a perfect square number. How about this? The positive value of the square root of 16. Think about this. So the square root of 16 is a perfect square number. Now, what is the positive square root of 16? It's 4. And 4 is a counting number. It's a whole number. It's an integer. It's a rational number. And of course, it's a real number. So you also have to be particular of the number inside the square root. So it should be, if it's a perfect square number, then of course it's a rational number. But if it's not a perfect square number, then it will be included in the irrational numbers, set of irrational numbers. How about this? Square root of -1. So think of this number, square root of -1. So square root of -1 is not a real number. So basically it is referred as a complex number. Actually, complex number or complex numbers are another lesson that, or it's another lesson that needs to be discussed. I will be posting another video lesson related to complex number siguro next time. But you have to take note that aside from real numbers, there are also set of numbers which we call complex numbers. So let's sum it up. Let's have a summary. So when talk about the subsets of real numbers, of course, real numbers, we have two types or two subsets. We have irrational and rational. So when we talk about rational numbers, so we have integers na belong na sa rational numbers. We have whole numbers na belong na sa integers and na belong na sa rational numbers and real numbers. And we also have counting numbers, or this is also called as the natural numbers. So I hope that this lesson will be able to help you in understanding your lesson. This is actually a grade 7 lesson, but I would argue that even the higher grade level students should also learn this, because they will be using this in their higher math lesson. So I think that's all for now. Thank you, more power, and let's keep learning.